Bienvenidos, Ushamdi, and welcome, CTS231, Section 841 students, for the second 8-week term in the fall 2017 semester at Anne Arundel Community College. This is the Networking 4, or the Connecting Networks V6 course, brought to you by Cisco Networking Academy. And today's Packet Tracer tutorial and solution set is going to be on our troubleshooting activity from last week, which is Activity 8.2.4.12. So let's go ahead and take a look at the activity and dig in here. We've got some nice troubleshooting activities here, and this is definitely one of them. You can see that this is very similar to the skills integration challenge topology that we were working with earlier with the sales, admin, production, and then we had the triangle of switches with probably a router on a stick configuration here going to router 3 with some outside hosts. So let's take a look here. We're going to go ahead, we've got our addressing table, so let's go ahead and dive right in. And so we've got a number of things that are going to be wrong. We got 60 total points. So switch 2 is the spanning tree route for VLAN 1, 10, and 20, and switch 3 is the spanning tree route for VLAN 30 and 88. So let's go ahead and bring switch 2 up here. And we'll tackle the switching challenges first. That way we can get to the routers where hopefully we've got a much larger text that we'll be working with. As you can see, the text is awfully small. So we'll take a look here and see what we've got. So we'll type in class for the password. So we need to confirm that switch 2 is the spanning tree route. So how do we do that? Well, we're going to say show spanning tree. And it's supposed to be the route for VLANs 1, 10, and 20. So here's VLAN 10. And when we take a look at VLAN 10, what we're looking for in here is the root ID, which here is, whoops, and it lowered us all the way down to 88 there, is the root. We had a little, okay, well, great. We see some native VLAN mismatch, so we know we've got an issue there. But back to VLAN 10, we were looking here at the MAC address for the root bridge. Is it the same as the local bridge? And it's not. So what this tells us is that switch 2 is not the root bridge right now. So let's go ahead and say show run. And this is probably not helping matters, right? So we've got this spanning tree for VLAN 1, 10, and 20, for which we are supposed to be the root bridge. And take a look at the priority that's been set. Yeah, the priority has been set to 61440. Now, that is the last assignable priority. That is certainly not going to make it so that we are the root bridge. So there's a couple of ways we can tackle this. Let's see which way the activity and the engine is looking for us to do it. I could say spanning tree VLAN 1, VLAN 1, 10, 20, and you can see they have the priority set there. So I could say priority 0. Right? And that's going to guarantee that for those VLANs that we are going to be the root bridge. And I hit enter. Now you'll notice that we didn't get the points. So since we didn't receive the points here, let's go ahead and say no spanning tree VLAN 1, 10, 20 priority 0. Let's say do show run. And let's take a look and see. All right, so it pulled everything out there. So if it's not looking for us to hard code that value, what it must be looking for then is spanning tree VLAN 1, 10, 20, and we're going to say root, and this is where we use the macro. So are we going to be the root bridge? Well, we are, so we're going to say primary, and we'll hit enter. And my guess is, yeah, okay, so there we go, 10 points for that. So now when I say do show spanning tree, and we take a look at VLAN 10 here, we can see that the root ID is the same as the local switch MAC address, and that's what we're looking for. And we should see that for VLAN 1, and we do, and 10, and then we'll come down to 20, and we see that same thing. So next on our list, switch 3 is the root for VLAN 20 and 88. So we don't want switch 1 yet. Let's take a look at switch 3 here, give ourselves a little more real estate to work with. And sure, we'll go ahead and do a large screen here. So we'll go from user exec to privilege exec with the enable command. Class is our password. And I'll say show spanning tree. Right, and let's go all the way down here, and we're going to take a look at 30 and 88. So is this the root bridge for VLAN 30? It is, because our root ID is the same as the bridge ID. And what about here? It is. So switch 3 for VLAN 30 and VLAN 88 look good. Now, let's go ahead, let's tackle this message because it's kind of becoming a little annoying here. So you can see we've got a native VLAN mismatch. Discovered on Fast Ethernet 03 and 04. So if we lower this down a little bit and we go back to the topology, we'll see that we have two connections. And here you can see switch 3's got 2 connections here and 2 connections here. So it's with switch 1. So it's on these connections here between switch 3 and switch 1 where we're using VLAN 99. And if I was to say show run, you can see our switch port trunk native VLAN is 99. If I was to look at switch 1, I would wager a guess that on switch 1, the native VLAN for those 2 ports you can see right here is probably not set, right? It is the default native VLAN. So we'll say class for the password, show run, and there you go. All of the trunk ports are actually left at their default value. So let's take a peek here. Yeah, the trunk links connecting the switches should be in VLAN 99. So let's make that happen here. So we'll go to global config. We'll go into interface range mode for FA 01 through 4. And we're simply going to say switch port trunk native VLAN 99. And that should earn us a few points, right? So it bumped us from 10 to 22. So that takes care of switch 1 as well as the mismatch that we were seeing while we were working over on switch 3. All right, so that should be it. Spanning tree root, and that was correct. The trunk links connecting are in native VLAN. Well, actually, let's do this. Let's make sure, and we can do this if I was to say do show interface trunk. So all of the switches should be native VLAN 99. So let's check switch 1. Let's check switch 2. Do show, we'll say do show interface trunk, a very handy command, and the native VLAN is good there. And last but not least, switch number 3, show interface trunk, and we are golden. Okay, so router 3 is responsible for the inner VLAN routing and serves as the DHCP server for VLANs 10, 20, and 30. So chances are, and this is actually a good thing here, we get to the routers where we're going to have a much larger font with which to work. And let me bring this down a little bit. So now, what are the issues that we could run into? And we saw some of these when we were working in the Skills Integration Challenge 8312. We know what we've got to set up. Now it's a matter of confirming or checking, validating what has been set up to make sure that it's set up correctly. So let's go from user exec to privilege exec with the enable password. I'm sorry, with the enable command, and the password is class. And let's do a quick show run here. All right, so for the 3 VLANs in question, and you can see that we're not excluding anything. We're not excluding anything for VLAN 88. And I'm pausing here. I'm looking at the setup to see if they were anticipating that's going to be done. So we'll keep that in mind. You can see we've got IP DHCP excluded, where the first 10 IPs in each of the address ranges have been excluded from the DHCP pools. And that's typically what we want. And so let's see here. So IP DHCP pool VLAN 10, VLAN 20, VLAN 30. The network statements look correct, and the default router statements look correct. So DHCP looks like it's correctly set up here for those 3 VLANs. Again, 88 is the management VLAN, but let's take a look at our sub interfaces here, and let's see what we've got. So we're making our way down ever slowly. All right, so Gigabit Ethernet 01 is the So interesting here. So we look here, we see it's gig 00 on router 3, but where is all the configuration work actually done? It's done under gig 01, not gig 00. And am I seeing that correct? Because that's a pretty big mistake there. Okay, that looks correct. So here's what we're going to do. I'm going to go into global config interface gig 00, and let's confirm. Let's bring this down a skosh right there. And it's interesting, the diagram is showing 01. And the addressing table shows 00. So this could be it could be a typo in the addressing table. So I'm going to shut that interface down. And it is a typo in the addressing table. I was going to say that would be a pretty epic mistake or series of mistakes on the sub interfaces. So it's not, I'll say no shut there. I'll bring gig 00 back up, even though it's not plugged in right now. We'll just put it back in its normal state. So when we said show run, what we were seeing was correct, that everything should be under gig 01, not gig 00, as the addressing table points out. So let's take a look here. And we've got 192.168.10.1/24.1Q incap. So the incap is good there. The incap is good there. So one mistake that I see right now, and it's a mistake that I have made during this term in one of these videos at some point, is Vlan 88. And I'm wondering, I'm looking for a note, curious to see if that is supposed to be 99 is the native Vlan on the trunks, and any special. No, so there is no native Vlan assignment here on our sub interfaces. So I am going to go ahead and leave that where it is. Let's see, let's get on to switch 3 and let's check to see what gig 01 looks like here. Because I said show interface trunk, you'll notice that the gigabit 01 interface is not there, right? And so that may be a problem. So let's say show run here, and let's go all the way down to gig 01. And it says switch port trunk native VLAN 99 switch port mode access, right? So it's set up as an access port. It's supposed to be a trunk port. And remember that by default on the Catalyst switches, ports are trunk ports by default, right? And if we want to hard code it as an access port, we need to go ahead and say switch port mode access. Now, DTP will negotiate, and if you plugged a host in, it would negotiate successfully. It'll default out to an access port. But here we've got it hard-coded, and when you hard-code it, it overrides the default behavior of the port wanting to be a trunk port. So let's get into global config, and let's get into interface gigabit Ethernet 01. I'm going to say switch port mode trunk. We're going to say switch port no negotiate, and how about switch port, and actually we've already got the native VLAN on there. All right, so that bumped us up another 8 points. So that was definitely an issue as well. We're going to leave the 99 with the same name. Or, I'm sorry, with the not the same name, but the same native VLAN. Okay, so inner VLAN routing services. So let's check some of these hosts out. Let's see if they're getting the information they're supposed to. DHCP, definitely not. That doesn't look good there. So let's go ahead and see when we request. All right, fantastic. So we've got an IP here, and that looks good. Let's check VLAN 20. So this should be a 192.168.20. So we'll click on static, and we'll come back to DHCP. So 192.168.20, right? And we're right outside that range, so outstanding. And then finally here, PC3. And again, we're not receiving points for this, but we've got to confirm that the DHCP is working, because that tells us then that our layer 2 network, right, all of our switching and spanning tree settings, that we've got connectivity and reachability, so we're good. Okay. All right, so routing. Each router is configured with Eigrp and uses AS22. Well, let's check that out, right? So let's say do show run here, and let's come down to the Eigrp config section. So that is definitely 22. Now let's take a look at how oops, I'll lower this down a little bit, how Eigrp is configured here. So we've got passive interface on gig 01, and that's good, right? Because we're not going to be sending Eigrp hellos out the LAN interface, because there are no Eigrp speaking devices out here. All right, we've got 1, 2, 3, 4, 5, 6 network statements, and auto summary is on. So my first guess is that that should be turned off. So let's go ahead and say router router Eigrp 22. And remember, we don't want it to auto-summarize, right? We want the masks, the net masks that we have in there, especially for the 10 networks here, to be taken. We don't want it to do any auto-summarization. So we turn off no summary. We don't get points for that, but we're going to stick with that. Now it's a matter of whether or not these statements are correct. So passive interface gig01, we're going to leave everything else non-passive. So this is interesting because I'm wondering if it's expecting you to put in here gigabit 01.10, because you should typically passive not just the sub interfaces, but or not just the parent interface, but the sub interface, and it doesn't appear that that's going to be required here. Let's say this, do show IP interface brief. All right, so 10.330, 10.220, are those the network statements we've got? 10.330 slash 30s, and that actually looks good in there on R3. So maybe R3 is good, although the passive command is actually throwing me for a loop there. I'm anticipating that we were supposed to, given the optimized keyword is not here, where it could get a little sticky in terms of which interfaces are they expecting to be passive, and do they want you to do the passive interface and then passive interface default and then no passive. And let's see if we can get this. What is my mouse doing here? All right, mouse is failing me here. There we go. All right, so let's take a look at router 1, and class is the password. We'll say show run here. And let's get to the Eigrp section, and there it is. So Eigrp 22, that's correct. And there are no network, or I should say LAN interfaces there, so it's literally those two. And again, we want to turn off, we'll go into global config, router Eigrp 22, no auto summary. And again, we're not given any points for that. Do show IP Eigrp neighbors. Let's make sure. Aha. So I've got a single neighbor adjacency with router 2. Let me pull router 3 back up, because I should have said do show IP Eigrp neighbor here. And I've got a single adjacency out the serial. So something is not right with serial 001. So let's take a look at that. Do show run. Let's see what's on serial 001. All right, so the in-cap is PPP. The PPP authentication is CHAP. And router 3, and so this is kind of leading us down another path here. Do show run. And we should see on serial 000, in-cap PPP, PPP authentication CHAP. So do show run again, and I want to see my usernames. So is there a username here or password? Okay, there we go. Username R1, password Cisco CCNA. Let's check over here. Do show run. And username, aha. Username CCNA, password 0 Cisco CCNA. So that is a mistake, right? So we need router 3 in here. Because if I was to say do show IP interface brief right now, we should see up, down, and we do, right? Very common problem we've seen here where the layer 1 connectivity is there, but the layer 2 connectivity, in this case, the PPP encapsulation method's unable to establish with the neighbor because we've got a mismatch in the authentication as it's configured right now. So let's get out of router configure. Say username R3, Cisco CCNA. Now that should bring the interface up. I'm also going to say no username, and there we go, new adjacency came up. So I'm also going to say no username, and what was it, CCNA, and then password Cisco CCNA, because we don't need that in there. Now, what is also interesting, we're on router 1. Let's check and see if the serial 000 interface, okay, so no authentication there. All right, and this is all kind of stemming from this EIGRP Autonomous System 22 troubleshooting that we've been doing. So do show IP EIGRP neighbors. Let's see, do we have our neighbors here? All right, we do. Let's come take a look at router 2 and see what we've got configured right now on router 2. So we've got our CLI. It looks like we're good. Class is our password, and so we'll say show IP EIGRP neighbors. All right, both adjacencies are there. And how about a show IP interface brief? Everybody is up, so that is a good thing. And let's do a show run and take a look at the EIGRP config. We've got a default route there, and I think I went right by it. Here we go. So we're redistributing the static route, right? We've got a static configured out the gig 00, and that looks incorrect to me. So again, just looking here, right, I was looking at this, I saw the redistribute static. We see our default static route that's configured here, but what is the egress interface that is listed? It's gigabit Ethernet 00, and that's going to take us to the TFTP server. We don't want that, right? We want this to take us out to the internet. So let's go ahead and get into the global config. We're going to say no IP route with the quad zeros. Whoops, we'll do the quad zeros. And then gigabit Ethernet 00, and we're going to rerun this command here. And hopefully we'll see some points for that. And we did, we got 10 points for that, so it takes us to 50. So we've straightened out that default static route. It now goes out the correct interface, but I want to look one more.time at the EIGRP config. And you'll notice there's no auto summary here, right? So we've got a 192.168.40 network, and then the two networks here. We know these are good, right? And then our redistribute static. So EIGRP at this point looks good. All right, so router 2 is configured. And let's make sure, let's say do show IP interface brief. Yeah, so all of our serial links are up. Let's check router 3. Let me double check this. Do show IP, whoops. Do show IP interface brief. Yep, everybody is up. And then router 1, we should have no issues. Do show IP interface brief, and that is up as well. So I'm assuming that we're going to have a NAT issue here. So NAT is configured on R2, and no untranslated addresses are permitted to cross the internet. So let's go back to R2 here, and let's give ourselves a little more room to work with in terms of this NAT configuration here. Let me bring this down. All right, so let's go ahead and say do show run. So just from looking at the configuration, we know that on router 2, our IPNAT inside statement should be where on router 2? Yeah, the gig 00, and then the serial 000 and serial 001. So let's check that first. Let's see if we've got our IPNAT inside statements. So IPNAT inside gig 00, that looks good. And we'll IPNAT, IPNAT inside on gig 01. Is this an inside interface? And the answer is no. My guess is that that is our last 10 points. No IPNAT inside and IPNAT outside. And that should, okay, we get 5 points for that. So there's still 5 points hanging out there. So let's continue to troubleshoot here. So gig 01, this is now correct. We've got IPNAT inside serial 00, IPNAT inside on the gig 01. Oh, I'm sorry. Yeah, gig 00 IPNAT in. There it is right there. IPNAT outside on gig 00. That's incorrect. Interface gig 00. So we'll say no IPNAT outside and IPNAT inside. My guess is that does it. So we've got 60 out of 60. Now the Lan Technologies, this was a section, and this question came up from a couple of you, David and Andrew raised this question, is that we saw that between router 1 and router 3, we were using PPP with CHAP. Between router 2 and router 3, we saw that we're just simply using HDLC. Now here, and this has got to be a leftover from the previous version of this course, it says the serial link between R1 and R2 uses frame relay. Okay, let's check that out. So the link between R1 and R2 is serial 000. That's what we have there. For the in cap to be frame relay, I would have to come in there and make a change. And so this is very misleading. And again, I think it's a mistake. Either it's a mistake, well, it's got to be a mistake because frame relay is no longer in the curriculum, number one. Number two, there is no frame relay configured on either side here between router 1 and router 2. So if I come over to router 1 and say do show run, you can see serial 000, there is no frame relay configured right now. So this gives you the impression that you've got to get in there and say in-cap frame relay, but all you could do, the only thing you could do here, right, would be back-to-back frame relay, right, which is definitely not inside the scope of the CCNA course, right? There's a way that you can do it over a serial link so that you can have sort of sub-interfaces using a serial connection. It's called back-to-back frame relay. But that is not what we're doing here, and this has got to be a mistake. So we've got the 60 out of 60. Those were the issues that we had. At this point, we should have full connectivity. So let's pull this guy up here, PC3. He's going to be our test pilot. And let's see if we can ping all the way out to 209.165.201.10. Probably going to have to ARP at least once. We're going to probably drop one, maybe two packets, and then we should have connectivity. And there it is. So now I should be able to come to R2 and say, do show IP NAT translations, translations. And we should see ICMP packets being translated, right? Here we go. And that is going to do it for packet tracer activity. 8.2 is 8.2.4. I forgot the number already. 8.2.4.12, the troubleshooting enterprise networks #1 activity. All right, guys, stay safe if you're out there in the snow traveling around shopping, and I will see you all on Tuesday night. Enjoy the rest of your weekend.